The lesson topic for this video is determining end behavior. So what this lesson is about is the fact that we have been talking about solving polynomials for a while now, and we're going to get into graphing them. And in order to graph them, we are going to want to pay attention to how the graphs, the ends of the graph, behave. Okay, so looking at where the arrows are, sometimes I refer to it as arrow behavior. So what are the arrows going to do? In order to determine what the ends of these arrows when we graph are going to do, okay, we are going to need to talk about the degree of the polynomial, the leading coefficient of the polynomial, and then determine the end behavior. There are only 4 ways that a polynomial's ends can be. If you think about this for a second, a polynomial can, it can end like this, where they're both pointing up. It could also be where they both end up pointing down. Okay. They can also one point down here and then move and point up, so increasing from the leftmost to the rightmost. And then the 4th is that it could be decreasing, where it starts up here and then it curves along and it ends further down. So opening up, opening down, increasing, or decreasing. Those are the 4 possibilities for how our ends could be. There's no other way that those arrows could be pointing. So again, to determine that end behavior, we need to know the degree and we need to know the leading coefficient. Okay? So, first of all, let's remember that the degree of a polynomial has to do with the highest exponent on the leading variable when written in standard form. So in this case, it's 4. So I'm going to write 4 for the degree because of this 4 right here. The second one, if you'll notice right here, we've got a degree of 5. So the degree is 5. Now, it's not actually super important what the number is, but that it is either even or it's odd. I'm going to explain why in a minute. So 4 is even, and 5 is odd. Okay? We'll get into why that is important in a second. Now, the next thing we're going to look at is our leading coefficient. And again, the leading coefficient is the number in front of the leading variable here. So this is a 1 and it's positive. Again, it doesn't matter what the number is, we just need to know that it's positive or it's negative. So that one's positive. And if you look at the second function right here, you'll also see the leading coefficient here is 1, which is positive. So in both of these cases, it is, positive. Okay. So with the information that the degree is even and the leading coefficient is positive, we're going to have enough information to describe the end behavior, even if we couldn't see this graph. Same thing here. If we know the degree is odd, and we know the leading coefficient is positive, we'll be able to determine the end behavior even if we couldn't see this graph. Okay, and I'll show you why on the next screen. We're going to connect these 2 examples to 2 examples that we are more familiar with, and that is linear and quadratic. If you think about the degree of a linear equation, the degree is 1, which is odd, so that's going to relate to this one. And if you think about a quadratic equation, a quadratic has a degree of 2, x squared, and that is even, so it's going to connect here with our graph on this side. You'll see what I mean on the next screen. Okay, so here we have examples of 2 linear and 2 quadratic functions. Okay? Again, if you pay attention to the end behavior that I was talking about on the previous screen, the arrows here, this is increasing from left to right, increasing, and the arrows here are decreasing from left to right. The arrows here are both pointing up, and the arrows here, if there were arrows drawn in, the arrows here are pointing down. Okay? So, let's talk about the degree of each of these functions. The degree of this function, again, when it's linear, it's a degree of 1. Because the x is raised to the first power, we just don't write it in. So the degree is 1, which is odd. Okay? The leading coefficient is, again, the number is in front of the 2/5 for our slope, and it is positive. And what does the end behavior do? Well, if you look at this graph, again, we just mentioned this is increasing from left to right. So we are going to write increasing. We know that that is how a linear equation will always look if we have this kind of information. We know linear is raised to the first power, which is odd. And then we know that if our slope is 2/5 and it's positive, it's going to be going up to right 5. It'll be an increasing graph. Okay? So the oddness of this degree and the positivity of the leading coefficient helps us realize that that will always end up being an increasing graph. Okay, so now the second graph, it's still a degree of 1, which is odd. Okay. And the leading coefficient this time is negative. Okay, negative. And we know that if a graph has a negative slope, it is decreasing. So again, this makes sense to us. We know that would be a decreasing line. Okay? So what's going to happen is if we have another polynomial that has a degree that is odd, it is going to behave like one of these two situations. It's either going to have an increasing situation or a decreasing situation. And that will always be based on whether it's a positive or a negative leading coefficient, increasing or decreasing. All right, so we'll talk more about that in a little bit. Let's go on to quadratic for a second. Now, quadratic functions, we know, have a degree of 2. Okay, and that exponent is 2, and 2 is an even number. So we're going to write that down here. All right. And then we're going to look again at the leading coefficient. The leading coefficient here is 1, which is positive. And we found out when we graphed quadratics, graphed parabolas, that if that leading coefficient is positive, the graph is always going to open up. Okay? So, up. This is nothing new to us. Okay? The second graph, again, the degree here is 2. Which is even, and the leading coefficient is negative. And when we learned to graph quadratics, we knew that if this value right here was negative, it was going to be opening down. So what's going to happen with our polynomial functions is if we have a degree that is even, just like quadratics, if we have a degree that is even, like x to the 4th power, x to the 6th power, x to the 8th power, we know it will either be opening up or down. And that will be determined by whether the leading coefficient is positive or negative. So now if we go back to the previous screen and we look at this, we can now say that since we know our leading coefficient, our degree is even, it's going to behave like our other even graph, which was which one, a linear or a quadratic? Well, quadratic, because even, like degree of 2. So this is behaving like a quadratic, which makes sense because we can see it's opening up. And again, it's opening up and not down because the leading coefficient was positive. The second example on the right here, this time we have an odd degree. And an odd degree is like linear, because linear is raised to the 1st power, and 1st power is odd. So we know it's either going to be increasing or decreasing based on if this is positive or negative. And again, in this case, we can see that it is positive, so it's increasing. So even if we couldn't see these two graphs right here, if we couldn't see these, we could look at just that exponent and leading coefficient, and we would know that this graph will be opening up and this graph will be increasing from left to right. Let's look at some other examples. Okay, so on this screen, and this is what we will practice in class the next time we meet, on this screen we're just going to be listing what's the degree, what's the leading coefficient, odd or positive or negative, and then determine from the degree and the leading coefficient what will the behavior at the ends B, or in other words, the arrows. So this first example right here, we know the degree is 3. So we're going to go ahead and write degree 3, which is odd. Therefore, it's going to behave like a linear function because a linear function is an odd degree. Okay, linear. The leading coefficient we see is right here is 6, and 6 is positive. So if it's behaving like a linear function, it's going to either be increasing or decreasing. And since it's positive, it will be increasing. Okay, now we don't know what exactly it looks like yet, but we do know the arrows are going to be one down and to the left, and then one of them will be up and to the right, increasing from left to right. Now the second example off to the right here, well, this time things are a little bit different just because this is not in standard form. Okay, so we have to think for a minute about what this would look like if it was in standard form. Well, we would have to FOIL this, and we'd get an x squared term, and then we'd take our x squared term expression, and we'd multiply it by another binomial, which means we would multiply that x squared term by x, which would give us an x to the third power. The degree here is going to be 3. And it kind of, if you're in factored form like this one is showing, your degree is going to be based on how many x's you see in each factor, in the factors. Okay, so the degree is 3, so again it's odd. So again it's going to behave like a linear function. So it's going to either be increasing or decreasing. The leading coefficient right here is 2, and 2 is positive. So this is another example of an increasing function. All right, so this one right here. Now what's the degree this time? Again, this is in factored form, but be careful and pay attention to double zeros. So in other words, this x is x squared, so that's 2 x's, right? And x times x. And then we have an x plus 3 squared. So that will be, again, if I were to do x plus 3 times x plus 3, I would FOIL it out and get another x squared. All right, so we have x squared, and we'll have another x squared if we were to FOIL this out. So x squared and x squared means we have degree of 4. Okay, 4 is even, so we know it's going to behave like a quadratic because a quadratic has a power of 2, a degree of 2, and that is even. So it's going to behave like a quadratic, which means it's either going to open up or open down. And that will all be determined based on if the leading coefficient is positive or negative. Since there is no number there, it's a 1 and it's positive, which means that the end behavior is that they are both going to be pointing up. Let's try another. Okay, again, this time we have an x right here, that's 1. We have another x right here, but it's squared, so it's 2 more, so that's 3. And then we have one more here, that's 4. So again, we have a 4, which is even, which means this will behave like a quadratic. It's either going to open up or down. That will be based on the leading coefficient, which this time is -1, so it is negative. So it'll behave like a quadratic that has a negative leading coefficient of a, which means it is going to be opening down. Okay, to sum things up, and don't worry, we will practice this in class and you'll catch on if you're not. Remember that the degree is even, it behaves like a quadratic. Okay, if the leading coefficient is positive, it's going to open up. If the degree is negative, it's going to open down. And then if the degree was odd to begin the problem, okay, we know it's going to behave like linear functions do. Okay, and if it behaves like a linear, it's either going to be positive leading coefficient, which means it increases from left to right, or it might have a negative leading coefficient and decrease from left to right.